Welcome back to SM219. Today is day 38, and today I'll be explaining some ideas about machine learning to you. First, let's move over and have a look at the website. Here we are on the homepage for SM219, and today is day 38. Today we'll be talking about machine learning, and we'll carry on talking about machine learning next class when we'll have a lab. Then in our next class, we'll talk about privacy and ethical considerations in machine learning, which I think are some of the most important and significant things that you should learn in this course. After that, we'll be into review for the final exam, and we'll have the final exam on the indicated dates. Let's go to day 38's demonstration page. If you go to day 38, you can download these files and follow along in the student version of the lecture notes as we go through. There'll be some exercises for you to work on. Here's the day 38 lecture notes. So today we'll be talking about machine learning, a method to get insight and make predictions from data. Machine learning is the engine that's powering data science to success in a diverse range of applications. For instance, machine learning helps classify breast cancer more accurately. It is used to make movie recommendations on Netflix. It determines posts you see on your Facebook newsfeed, and it tells self-driving cars what actions to take. Why is machine learning so popular now? Well, many factors contribute to machine learning's recent period of unprecedented success. Massive amounts of data are collected and stored by all sorts of entities. Government collects weather data. Private industry tracks customer purchases. Financial firms track stock market movements, and internet providers store your browsing history. Taken together, these data sets can tell you a lot about our society, our economy, and even about individual people. 20 years ago, we didn't have the processing power to take advantage of all this data, but computers tend to improve. They tend to improve their performance based on Moore's law. They double processing power every 3 years. That exponential growth has brought us to a point where computers today can process massive amounts of data very quickly. Furthermore, machine learning algorithms have improved tremendously. Today we hear about algorithmic methods such as deep learning or reinforcement learning. These ideas are helping us tackle really hard problems. For instance, the company DeepMind built AlphaGo, a computer that beat a legendary Go master recently. That was something that was unthinkable even a few years ago. That same technology could have important implications for the US Navy. What if our adversaries get an alpha navy, a navy whose strategic planning and tactics are determined by artificial intelligence that operates on a superhuman level? What if we could access that technology before our adversaries? The US Navy is heavily invested in artificial intelligence, data science, and machine learning. For instance, our aging F-18 fighter jets are breaking down more frequently than expected. This is hurting our readiness levels and ability to project force from our aircraft carriers. We've gathered massive amounts of performance and maintenance data on classified computer servers. Now the US Navy is turning to data scientists to try to improve our maintenance activities so that we can repair jets before they break and keep more planes in the air. This was the broad area of activity for both the Data Sustainment Challenge, whose final competition was held at the Naval Academy in June of 2019, and for the Navy's Hack the Machine Hackathon in New York City in September 2019. In the next video, we'll look at supervised versus unsupervised learning and delve further into different kinds of machine learning problems.